Welcome, everyone. My talk today compares a risk-aware approach to options with a risk-neutral approach. In the risk-aware approach, we assess costs of attempted replication of a sold option. This attempted replication cost has an adversely asymmetric distribution. There is no perfect hedge in the real world. We define the deviation of an option price from the expected replication cost as a risk premium. In contrast, the risk-neutral approach sets the observed option price equal to an expected payoff under a risk-neutral probability measure that can only be inferred by fitting to observed option prices. A risk-aware approach must address real returns. Even if all market events occurred randomly at a high frequency, human reactions to these events occur at a human timescale, with associated herding tendencies and emotional expressions of greed and fear, leveraging and deleveraging. For the S&P 500 index, the return sign indicator leads the return magnitude. The presaging of higher return magnitudes by downturns is significant because the return magnitude itself has a significant autocorrelation that decays slowly. Help does not arrive soon for those glibly invoking a central limit theorem to argue away any departures from normality. Certainly, the smaller the timescale one looks at, the less tenable the Gaussian assumption becomes. White noise is not a good model for human interactions, which control price discovery in markets. Our tool to describe the asset is a real-world stochastic model. We exploit observed persistence and lead-lag relationships between return magnitude and sign and other conditioning variables using a vector autoregressive framework to realistically capture the first 4 moments of return term structure. Our tool for analyzing options is multivariate variational calculus. The pair of optimal functions being sought are the hedge ratio and expected attempted replication cost as a function of the underlying. The functional being minimized is the wealth change variance. An explicit articulation of the optimal hedging strategy at each time step enables an ex-ante assessment of residual risks. We infer option risk premiums by comparing option price with expected costs of attempted replication. We can normalize this risk premium by dividing by tail loss, downside deviation, or standard deviation of the attempted replication P&L, and express it in terms of rate of expected return on risk capital, Sortino ratio, or Sharpe ratio. These normalized risk-return ratios guide our view of the surfaces of opportunity in the options market. Irreducible risk while attempting to replicate our fact of life. What does the risk-neutral approach mean in the presence of irreducible risks and associated risk premiums? What is the meaning of the option price fitted probability measure in the presence of risk premiums? Can fitted risk-neutral measures accommodate risk premiums? Single period static hedging provides the simplemest problem to simultaneously analytically display the risk-aware approach and examine the risk-neutral approach. The risk-aware approach finds an optimal hedge ratio and quantifies the residual risks. The two-state asset problem is trivial insofar as the irreducible risk is 0. For the 3 and more state, the residual risks are not 0. The expected attempted replication cost is assessed, and we have a model option price using the irreducible P&L standard deviation as the driver of risk premium. Let's try to fit risk-neutral probabilities to the expected replication cost. These probabilities exist and are unique. Now let's move to a plausible option price that includes a risk premium driven from the irreducible P&L standard deviation. We can in fact find a risk-neutral probability set. However, it's only unique for a very limited set, i.e. 3-state asset with homogeneous risk premium parameter lambda. For heterogeneous lambda and/or the 4 or more state problem, while each individual option price may be fitted by a risk-neutral probability set, that set is not unique for even our simple risk premium model. To conclude, one finds that most option contracts involve hedge slippage that is at least the same order of magnitude as the average attempted replication cost. Hence the practical relevance of acknowledging risk premiums. Fitted risk-neutral probabilities, as such, do not shed light on risk premiums. On account of irreducible risks, a unique risk-neutral probability measure fails to exist. This work was done in collaboration with Vivek Kapoor. For references, please see the Valaris Capital research page. Thanks so much for having me.